Maintenance process. So this is a 2-slide overview of the 12 steps in maintenance, and these steps are not essential in the same way that the maintenance process is essential. You can actually skip some of these steps from one project to the next. Instead, I want you to think of this as simply one way of approaching the process of maintaining a system, one way of having a coherent, repeatable, systematic approach to maintenance. In general, whenever you end up going off into industry, you'll probably end up joining an organization that already has a fairly well-established process that looks something like this, and you should do that. If you are starting your own company or doing your own thing, this is not a bad process. It's a good high-level skeleton that you could then modify to your own needs. So the first 6 steps are here, and the next 6 are on the next slide. The first thing that you're going to need to do is have some mechanism for prioritizing change requests. There's a general Eisenhower chart on urgent versus important. I think that's a useful metric to start thinking about. Often we end up doing only the things that are urgent, even if they are not particularly important, and leaving off until tomorrow things that are important but not particularly urgent. And so you want to make sure that your prioritization scheme has some way of accommodating for those kinds of problems. Step 2, you want to select and change parts of the system that are appropriate for funding purposes. At the end of the day, most software systems are there to provide some financial benefit. Most of the time this is going to align really well with what the user is wanting, but sometimes it doesn't, and your organization really is more interested in making sure that they are able to stay financially solvent. So it is at least worth having some system in place so that you can verify, is this actually worth the money for us to do it? That said, there are organizations and nonprofits out there who have a mission that is not entirely driven by funding. They still have to make decisions based on where it's the most appropriate to allocate funds. So you need to make sure that this is an early part of your maintenance process. And finally, I would just say along the same lines, you want to incorporate ethics very early on into the process for selecting which change requests to work on. For something that doesn't make a lot of money, if there is a serious ethical problem or a serious concern that would be, if it were realized, a large security issue, privacy issue, something like that would affect your customers. Even if that does not make you very much money, it's the kind of change requests that you may need to include very early on. So step 2, make sure that you have some process and can fund it appropriately. Step 3, using configuration management to figure out which component of the system needs to be changed, to update it, and then to incorporate those changes back into your deployed system is crucial. No software system of any size can be maintained appropriately if there isn't a configuration management system that would allow for you to update those components individually and guarantee that they're going to work on all of the deployed hardware that's required. Step 4, you want to make sure that the documentation for the component has been made available to the people who are maintaining the system. Going back to some of the problems that we identified in the last set of slides, you'll note that much of that is knowledge related, especially if you have had a lot of turnover in your project or you no longer have any of the original developers on the team. The documentation is going to be critical for you to be able to maintain a software system long term. So don't let this slip. It is the kind of thing that can be skipped and is often skipped in some organizations, but don't let it slip too much, or else you'll find yourself in a position where no one on the maintenance team understands anything about the software that's currently running, possibly critical part of your business. Step 5, you want to have some understanding of the component that's going to be modified. This is a purposeful step where people are exploring and understanding exactly how it works right now, or exactly why it's failing right now. And you shouldn't rush this. This is the kind of thing that a lot of organizations want to rush simply because when you have a change request of this nature, generally you're already feeling some pain, right? The system is failing in some way, or there's features that are missing that are critical in some way. But you cannot skip this process. Again, going back to that last set of slides, much of the problem of maintenance is a knowledge problem. Making sure that people understand all of the components saves you maintenance money in terms of not having to go back and refix something that you thought you had previously fixed in the last cycle. And then step 6, you want to propose changes that could actually implement the new functionality or correct the missing functionality or what have you. And this should be very similar to the proposal process that you have for designs during the design phase prior to implementation. You want people to review this proposal and possibly make suggestions to correct and improve it. It's intended to be very similar to the design process that we outlined earlier in the semester. Step 7, you want to change. You want to select which change you actually are going to think of as the optimal one that you're going to implement in real software systems. This is often very similar to the design phase as well, when you are choosing one option over the others of what to implement and how. Step 8, you want to produce some kind of a specification for the change. This is critical for 2 reasons. First, the specification will actually be something that you can use as documentation down the road of what the current system looks like. It's your opportunity to correct any errors that you found in the documentation or in the existing system that you were struggling to understand when you started first looking at this issue. Second, a requirement specification is another opportunity for you to see if your design is actually going to address what the system stakeholders need it to address. You can think of this as another bite at the apple for validation. Is this actually the right product that we wanted to be building? Step 9, given the change analysis, actually implement the change. This is probably the most straightforward step. If you're building software systems, at some point you have to put code into a system and compile it. This is that step. Step 10, test it. Now this is the part that a lot of organizations end up skipping to their own detriment. You must test code that you are using for maintenance. It is the kind of thing that can be very buggy, especially given all of the knowledge problems that go into understanding each of these code modules. At some point, this may be the code that has been written by the least experienced engineers for the people who wrote the rest of the application. Because you will have people leave the team, they won't have all of the same experience as the folks who originally designed it. They may be working with older code, older frameworks, things that are no longer current. So you must test the resulting code prior to deploying it. Step 11, update all the documentation, including the change log, to represent all of the changes that you've made when implementing this code to fix whatever it is that you're fixing. And then step 12, use your configuration management continuous integration tool to check the software back into your version control system and deploy it to the live server. So those are the 12 steps in maintenance, the 12 steps that I think probably are a reasonable outline of what you want to do when you're doing maintenance. Normally at this point in the class, I would ask you to get with a partner or with somebody and just very briefly think about which of these steps would be most skippable. So I'll pause the video and let you give you an opportunity to think about which of these steps would be most skippable. Common answers to that question include the documentation, right? Identifying all the documentation, or updating all of the documentation. Where is it? Yeah, updating all the documentation. And those are often skipped. I don't think it's a good idea to skip them regularly. It's the kind of thing that ends up biting you quite a bit down the road, especially if you're going to be maintaining the system for years to come. Documentation becomes absolutely crucial to being able to do that well. Sometimes I think, especially if you have a really pressing, urgent problem, this is the step that's most skippable. Instead of optimal in terms of like what is the most optimal change, you might just want the first one that works to kind of stem the bleeding depending upon the kind of maintenance concern that you're experiencing. And then you can kind of go through all 12 of these steps again, looking at optimal engineered solutions to address whatever the problem was. I will say just briefly, one thing that I've heard a lot of students in the past mention skipping, but is probably not worth skipping is the configuration management step here in 3 and 12, right? I think that is the kind of thing that if you are just, especially in a web application, editing a live web page or a live web app is very, very dangerous. It's the kind of thing that can take a standard maintenance problem and turn it into an extended downtime process very, very quickly. So make sure that you are not skipping steps 3 and 12, or that your organization has some notion of steps 3 and 12. All right, let's move on to program comprehension, because many of the problems that we've outlined with maintenance are about understanding what is in a piece of source code, and that's program comprehension. Standish Group ends up estimating somewhere between 50 and 90% of the overall cost is really about the overall cost of maintenance in particular is really about trying to figure out what is going on in the program. And this makes a lot of sense when you start thinking about all of the reasons why it may be difficult to understand source code that has been deployed. Most of the people who are working in maintenance, especially as the program ages, were not there for the original development, right? So they have to begin understanding it from scratch, and many of the frameworks and techniques that are used to build software systems age badly. And sometimes that requires people who are learning something for the first time to not only learn something for the first time, but also learn how it was built back in 2005 or 2006 or whenever the software was originally designed and laid out. So much of program comprehension is all about acquiring knowledge about the program, the documentation, the procedures, all of the things that were built or used to build the software system originally. And this is, of course, even more critical for legacy systems. Again, I would point you to the COBOL system in New Jersey that was running their unemployment processing system. Very, very difficult to understand what that sort of code looks like. COBOL is a very different kind of language than modern computer languages. Okay, so program comprehension strategies. You can actually do this in two different high-level ways. One is to be systematic about it and think of the entire program as worth examining, and then make sure that you've actually established all of the high-level interactions between components within that program. And then you'd only start maintaining the system when you've got a good understanding of the high-level elements of this software system. In contrast, you could do something like an as-needed strategy where the maintainer is really only trying to understand the part of the program that seems to be failing right now and creating a partial model of how that component works prior to doing any sort of maintenance. There are trade-offs, and of course these are basically the two ends of a spectrum, that in between which you may actually draw the line somewhere more appropriate for your particular organization. I don't know that there's a right or wrong answer to which strategy you should use. It very much depends on the kind of program that you're working with, the sorts of problems that you're running into, and the type of maintenance strategy you have long term. So for example, if you were planning on maintaining the software for the next decade, maybe you'd lean more towards something systematic and trying to figure out all the interactions before you do any sort of maintenance. On the other hand, if you have an immediately pressing problem, or if this is a legacy system that's going to be phased out in another 6 months, it may be more appropriate to do something that leans more towards the as-needed side of that spectrum. In either case, it's something that you can't universally answer as good or bad. It's just a process and a framework that you could use to guide the kind of decisions that you're making in the maintenance lifecycle.